All right, this lecture is going to be on Git and GitHub. So Git is a version control system often used by large code development projects to track and commit changes or additions to the code base. So these, we use the word commit often. Commit just refers to a snapshot in time of the code base. And again, you're probably often used to version controlling your own documents, even Word documents in some way. Often a very crude way by just changing the file extension to, V1, V2. This is a more systematic way to track changes, to be allowed to go back in time, and other things like that. Just coincidentally, or I guess not necessarily coincidentally, but important, not that important, is the fact that it was written by Linus Torvald, and it was written by Linus Torvald to manage the Linux kernel project. So of course Linus Torvald is the namesake of Linux, Linus, and he wasn't happy with the old central version control systems like CVS and SVN, and decided to create Git to manage the Linux kernel project. So a little bit about just the history of version control, or the difference between central version control and what we call distributed version control. So Git is a distributed version control tool, as is Mercurial, although Git is far more popular. So again, you have a code that is a collection of snapshots we'll call V1, and derived from V1 is V2, and derived from that is V3. And the collection of all of these commits or snapshots in time we call a repository. So the repository contains all of the history of the code. It used to be that this repository would often live at a central server, away from a local user. So if we have a user, we'll call him Romeo, and he has what we'll call local, meaning on his machine. And if Romeo wanted to work on this code locally, he would have to check out the latest version of the code. So he would have a copy V3, which then he could make changes to derive a new version V4. And then potentially, if he wanted to have those changes stored, he could then push that back to the central repository where it would be stored as well, any changes that he might have made. However, if you have another user, Juliet, who also is working locally, if she were wanting to collaborate with Romeo, say Romeo made some changes to the code, we'll call V5, but Romeo needs Juliet's help to complete these changes. In a central version control system, he would have to send this V5, which could be potentially a non-working or incomplete set of work, to be basically stored forever in the central repository, so that then Juliet could check out that version of the code, make changes, potentially deriving a sixth version, and then send those back to the central repository. And this is inefficient for several reasons. It's quite possible that the version 5 version, this was our incomplete feature, if you will. Well, we don't necessarily want to store incomplete changes in our code, or non-working changes. We often want our remote code base to just only contain the major bug fixes or feature changes. Any kind of incremental work is not important and doesn't necessarily need to be stored in the central repository. And so in a So in a distributed version control system, then you could have the same setup where you have a repository of commits stored in some remote server. It could be in the cloud or on a system server, that's external to your local machine. And whenever you then check out, want to make changes to the code, the user would actually get his own complete copy of all of the changes of the code. So again, this is Romeo. And if Romeo made a subsequent change that he needed help on and wanted to collaborate with Juliet, well, then she could actually check out the code and all its changes directly from Romeo. So she could actually grab this, make her own copy over here that would be identical to what Romeo has, and include his changed version 4, which then she could derive either, another version 5, which completes the changes, and then she could actually then send those back to Romeo to add to his repository, and then he could send them back to the remote, or she could send them back to the remote directly because they have a common history. And this kind of thing would go on. So again, a couple of key things. The collection of commits is called a repository. Each commit itself is a snapshot in time that we want to preserve the history of. In a central version control system, and again, the classic examples are CVS and SVN, the local user only has the most recent version of the code, whereas in a distributed version control system, which includes Git and also Mercurial, there are probably others, but the two big ones are Git and Mercurial, with Git being the biggest by far. In those, then each local user has an entire copy of all of the changes. And Git is smart enough that, each of these commits, as I progress from version 1, to in this case I wrote v3, but whatever, version 2 or the second snapshot in time, imagine if only a small amount, imagine version 1 contained 100 lines of code. And the only change between version 1 and version 3 here is one typo on one line. So literally maybe 2 characters of code have changed. Well, version 3, Git is smart enough to only sort of capture the 2 character change between version 1 and version 3, and it doesn't need to it doesn't require an entire copy of the 100 lines of code in version 3. So it's very smart in the way it tracks the changes from one commit to the next, and it allows it very efficient use of space and memory, because code bases can become quite large. And so if you're constantly pulling down the entire repository, the entire history, whenever you want to work on it locally, that could be a very slow process if it wasn't a very efficient tracking between the versions. Okay. So to create a Git repository, and a repository on the file system resides inside a folder. We'll give an example of that. But so to create a repository, it's as simple as typing git init. So if we go over to Jupyter Lab, launch a terminal window, first thing we have to do is create a folder or a directory. We'll call it my repo in this case. If I want to turn this into a Git repository, it's as simple as git init. So it gives us some information there about our repository. And you can see a couple of things. One, if we type git branch with no arguments, So a couple of things. If we type git status, it will tell us that we're on branch master and there are no commits yet, right? And in this case, there are no commits, there are no files. So let's go ahead and add a file. We'll just call it file.txt, and we'll add some text to the file. And now if we type git status, it will tell us again we're on branch master, there are no commits, but now it tells us that we have untracked files present, file.txt. And so if we want to track this file, meaning track its history as we make changes to it and make commits, what we have to do the first time is we have to explicitly add it to the repository. So we'll say git add file.txt. Again, type git status. It will now tell us there are changes to be committed. And there's a new file there, file.txt. And so we'll go ahead and make a commit. And the commit message can be presented on the command line by using a -m, and then we'll just call it first commit in this case. So we're going to make a commit. Its commit message is first commit. And now if we type git log, we can see the history of that commit, right? So a couple of things. There's this long hash right here. This is a series of numbers and letters that make this commit unique. It's a unique series of net letters and numbers that allow us to refer back to this commit. Of course, it also tells us who made the commit, at what time, and the short version of the commit message, okay? So to demonstrate a little more utility, we can go on and we can add additional things to my file. So we'll just add another line, okay? Again, what we're writing in the file is not really what's important here. It's just the fact that we're making changes. And we can actually type git status again, and now it tells us that we've modified file.txt. Now, because the file has already been added for tracking, we don't need to do the explicit add again if on the command line when we write git commit, we use the -a. The -a is shorthand, meaning track all files that are or add all files that are currently being tracked to this commit. So in this case, we'll give it another commit. Of course, your commit messages should be more informative, but that will be easier when you're writing real code or doing something meaningful instead of just demonstrating Git through making meaningless changes to a file. But nevertheless, if we do that, we type git log, and we can see our two commits there. Okay, so if I were to look at the file, file.txt, we can see the 2 lines of code in there. Now what we can do is at any time we can go back in history. In this case there's only 2 commits, so we'll have to go back to the first commit. We can go back to that commit to say look around, see what was there and other things by typing git checkout. And we only have to type enough of the string to make it unique. So just usually 4 or 5 letters is plenty. And now we're back here, and if I do cat.file.txt, we can see there's only 1 line of code in it. So the second line of code that I added is not there because we went back in time and we're looking at an older version of the code at this point. There's also a message about detached head and other things, but we won't worry about that at the moment. To return to the most recent version of the code, I'll just type git checkout master. Master is the default name of the branch that is created when you type git commit. Okay, so if we type git log now, we see there's a couple of commits there. Okay, I guess just for demonstration, I'll go ahead and I'll make one more line of code change. And this is the 3rd line of code, and make a commit. And this time, what I'm going to do is I'm going to put the -a, meaning include all files, but I'm not going to put the commit message on the command line. And if you do that, then what it'll do is it actually opens up an editor, and so it will go ahead and say, And the typical protocol here is to write a short commit message on the first line, followed by a more descriptive message. So then if we type git log, what you'll see is the third commit, and you'll see a few more lines of code, right? So I have some stuff in the notes about what good commit messages are, but nevertheless, that demonstrates the fact that if you don't put the -m on the command line, then it's automatically going to open up an editor and force you to put in a commit message there, okay? So returning to the slides for a minute, we've already covered a few of these things. Git status tells you, again, what the status of the repository is for both tracked and untracked files and any changes you have made. To explicitly add a file, we do it with git add. To add all files in a directory, you could say git add period. Remember, the period is shorthand for the current location. One problem with this is it's not rarely a good idea to do this because you're going to have hidden files and other things in your folder that will be added to the repository that you don't necessarily want to track. You typically only want to track source code files in a repository. You don't want to track intermediate files that can be reproduced through compilation or anything like that. So it's usually a good idea to explicitly add the files you want to track the first time you need to. We've already covered the commit message and what the -a option, and the fact that if you omit it, it's going to open an editor for a longer commit message. Here's some notes on good commit messages. Write your commit message in the present tense, fix bug and not fix bug. These are conventions, but the idea behind that is that if you write it in the past tense, it might not be clear if this was something was fixed or changed in a previous commit or in the current one. So you want to, if you speak in the present tense, then it's obvious that whatever description you put there is associated with the present commit. So if you want to have files that you don't want to appear in the listing, so the best way to show this is through an example. A lot of times we'll have hidden files that are in our directory. So for example, I might have a file just that's called .config. And so if I do a long listing of the directory, you can see the .config file there, okay? And of course, if I type git status, well, it also shows up as a file that you may want to add to tracking. However, we don't ever, this will be, the example here would be a case where .config, we would never want to add it to the tracking. And so we can actually create a special file called git ignore. And then if we put the .config in there and save it, next time we type git status, we won't see the .config. It's been ignored. Of course, now we see the git ignore file. But it's often that you want to actually commit that to your repository itself. And so in this case, we can say git add, git ignore, git commit, add. So now we have a fourth commit, and if we type git status now, we won't, it says nothing to be done. We're working on a clean working tree. So that's example of a git ignore file. If you have files that are tracked and you want to remove them from the repository, you can use git remove. If you only want to remove the file from the repository but leave it in your working directory, then you can remove git remove cached file.txt. So let's go look at an example of the difference of these two. So again, if I type git remove file.txt and then type git status, you can see that it's telling me that we deleted file.txt, and not only is it deleted from the repository, if I do a long listing of the directory, you can see it's not there. So we've actually deleted it from the hard drive as well. So it's been removed from the Git history. It's been removed from the current directory and potentially the next commit, but it's also been taken from the hard drive. We could also then, in this case, we can get that file back from the last commit. So we can just say git checkout from master file.txt, because it is stored in the last commit, and now it's there again, right? So if we want to actually remove it from the next commit but leave the file on our hard drive, then that's what git removed cache would do. And so in this case, it's on our hard drive, but if we type git status, you can see that it's been staged as delete for the next commit, right? So if we typed git commit, so now it's there locally on the hard drive, but it's not in the commit that we made. So anyway, we can go back and add it explicitly, and we'll possibly do that in just a second. So if you want to go back in time, say go back to the previous commit, what you can use is git revert. So head means the previous commit. To go back 3 commits, you could use the syntax head ~3. If you want to go back to a specific commit, you can actually use the commit string. And I always find that this last one is the safest thing to do. And so, for example, and I want to be real clear about, there's 2 commands we'll use. One of them will be git revert, and the other one will be git reset. Okay, and I want to talk about the difference between those 2 briefly. So with a revert, what you're doing is, say you have a commit A, a commit B, and then you make a commit C. However, you discover that C breaks your code, and it's something that you want to revert or go back to B. Well, if you type git revert, so if you use revert, okay, what it's going to do is make B, I'll call it B prime, B the most recent version of the code, but preserve the changes in C. So you'll still be able to go from B prime back to C to perhaps get some code that you might have written in there, but it's not gone from the commit history. However, if you use reset, and say you were then at C and you want to reset, in the event there, it literally would remove C from the commit history completely, and any changes that you would have put there are gone irreversibly. Okay, so that's kind of the difference between reset and revert. Okay. Again, I often just use the syntax for reverting via the command. So if we wanted to return to a state where we had file.txt in our Git history, we'll go ahead and remove file.txt from the hard drive, so you can see it's gone. And if I type git log, well, the last commit where it actually was this one, 62A7, right? So if I copy that part of the commit message and type git, in this case what we could do is say reset. Then if I type gits, or if I just list the directory, you see file.txt is back. And this is because we've went back in time. In fact, if we type git log, you'll see the commit where we removed file.txt is not even in the history anymore. So that we just discussed, git reset. So if you want to clone remote repositories, this would be like, for example, from GitHub, and we'll have an example of that soon. then you would type git clone and you would follow it by the URL to the remote repository. Now GitHub, which we're going to discuss in more detail shortly, is a cloud-based repository, hosting service for repositories. But you can have a remote repository that's not necessarily hosted in the cloud or on a via web interface like on GitHub. You could have this repository could just be on another machine in your office. It could be on another machine within your local area network or whatever. Okay. If changes are made to the remote repository, you can pull them to your local with the syntax git pull origin master. So git pull is the syntax for starting initiating the pull of changes from the remote repository. Origin is the default name for the remote repository. So just like master is the default name for the master or a branch, origin is the default name for a repository. In this case, it would be GitHub, but it could be anything. And you can change these names. It doesn't necessarily always have to be origin. That's just the default that's given automatically if you don't provide any additional arguments. Again, to push to a remote repository, you would make a commit message, you'd make a commit along with a message, and then push it via the git push origin master. So you're going to push this to origin, and in our example here would be GitHub, and you're going to push the master branch. And so far we've only dealt with one branch. So there are advanced features, branching and merging. Let's go ahead and look at those just from an example perspective, or kind of two use cases here. So a couple of use cases would be something like this. You have a repository that has some changes, and at some point possibly you're maintaining this code and one of your users writes you an email and says he's found a bug in the code. So it's often the workflow or desire that you want to keep your master branch clean, meaning any changes that you make here should be working. They shouldn't break the code in any way. So often what you'd like to do is, instead of attempting to fix it, which could potentially cause other problems from the master branch, what you'd want to do is create a new branch that would allow you to work without any changes to master at the moment, and until you can definitively test them and other things, right? So we'll call this branch bug fix. Okay, and at the moment we create the branch, it'll be an exact copy of B in this example, and then that'll allow us to then make additional changes. Could be C. And once these changes have been tested thoroughly, then we can actually push them back to the master branch here, and that operation is called a merge. Okay, and so let's go through an example of that over in the terminal. So we have our code base, and just to remind you, the state of file.txt has 3 lines of code. Let's say that we get a notification that says that our code is broken, and so what we want to do is create another branch. So we can do that with git checkout -b for branch. We'll call this branch bug fix, right? And so that tells us we switched to a new branch. In fact, the way I have my terminal window set up, you can even see it there on the prompt that we're on the bug fix branch. You can also get to this by typing git branch. So if you type git branch, it'll tell you with the asterisk what branch we're on. There are only 2 branches around right now, bug fix and master. This will allow us to then go ahead and make some changes to this case. We can actually just say fixed bug here, and then we'll go ahead and make a commit. Now this commit is going to be on the bug fix branch, right? So if I type git log, you'll see the bug fix commit we just made, and it also tells us that we're on the bug fix branch, and that master is one commit behind. Okay, so if we return to git checkout master, returning to master, again we can look at file.txt. There's only 3 lines of code there, no bug fix yet. Okay, so to get those changes from bug fix back into master, what we would do is type git git merge master bug fix. So that's going to merge from bug fix into master, and it will tell us some information there. And now if we look at what's in the file, you can see that that's there. And if we type git log, you'll see that the bug fix commit is now appearing in master, and it tells you, basically master and bug fix are both there together. So the workflow then often, if it's just a simple bug fix, is to delete the branch afterwards. So we can type git branch d bug fix. So now if you type git branch, there's only one branch in it, and it is master. Okay, so another sort of extension of this kind of workflow would be, again, we've now completely deleted the bug fix branch. It's no longer there. But our code base is here at C commit, which is the commit that included the bug fix. Okay. Another scenario would be where, say, you were going to add a new feature to the code. So we'll just call this branch new feature. And again, we'll go ahead and create the branch. It's going to be an exact copy of C at the time we make it. Okay. But the new feature is going to be much larger than just a single commit, because we're going to make incremental commits on the way as we make changes. Okay. And what we want to do, these intermediate commits, say D and E, right? Say we get to a point where F is our new feature works, so we've tested it. Everything works well. But these incremental commits, say D and E, they were just, they're unimportant to any other user of the code base. These were incremental commits that, me as a developer of this new feature needed for my own work. But really what I just want in the code base is to go from the place where there wasn't a new feature to the place where there is a new feature and it's been tested and it works, okay? And so this is called a squash merge, right? So squash meaning we're going to squash all of these commits down into one commit that's only going to be retained, and then that will go into the history there. So let's look at an example of this real quick in the terminal. We have to make a few changes and a few commits. We'll start with making the new branch, git checkout new branch we'll call new feature. And we'll edit our file. And we'll make a commit. First commit on new feature. And we'll edit the file some more. Make another commit. An intermediate. Commit on new feature. And we'll make one last change to the file. We'll just say new feature works. And finally make another commit. So I need to add the -a there to ensure that that's stored. So with this, if we look at our git log on the new feature branch, you see there's 3 commits between where master was the first commit on new feature, intermediate commit on new feature, and now new feature works. The only thing we really care about on master is that the new feature works, and we want to have that commit in there. And so what we'll do is do git checkout master, git merge master new feature, with the additional option squash. Now we'll have to make one more commit. What I'm just going to do here is just type git commit without any message so that it opens up a box. And in this case, it actually populates the commit history with the 3 other commits, right? The messages and the times, right? So then what I'm going to do is say, new feature. This new feature is the squash of the following, right? Or of course there's a line there that already says that, but nevertheless I could delete these lines if I want or leave them, make the commit, and now if I type git log on master, you see there the longer commit message, but there's only one commit difference between the bug fix commit and the new feature commit. So those incremental commits that weren't really important to any user of the master code base are gone. They've been squashed out of the commit. Okay? So that's a quick example of branching and merging. GitHub, right? So GitHub is a cloud-based remote repository server. Has unlimited public repositories, meaning if your code is open source, if anyone can access it and see it, then you can have an unlimited number of those associated with your account. There are private repositories available with different pricing plans. There's teams and organizations. And most usefully, there's this integrated pull request and code review system. So it's really a great way to collaborate and look at visualize changes to codes and other things. Just so you know, there are similar services, Bitbucket, GitLab. GitHub is by far the most popular. It was recently purchased by Microsoft. So I have an example here we're going to look at. Under the Datum organization, there is a repository called GitHub merge exercise. And so the first thing we want to do is we're going to create a fork of this exercise, right? So if I click fork, it's going to, in my case, I have a lot of organizations that I belong to, so it's going to ask me which should I fork it to, and I'm just going to fork it to my personal account. The fork is just a copy or clone in the cloud, is one way to think of it. It's not exactly that because there is some tie back to the original version, and you can see that there. But now you can see that this is under my own account. So John T. Foster, there's a repository called GitHub merge exercise. Now this repository just has 3 things in it: a license file, a README, and an email. But we're going to make some changes to this file and see how we would send those back to GitHub. So the first thing we're going to do is we need to make a clone, that is a local copy of this repository on our machine. And you can do that by clicking this green box and then either highlighting and copying or clicking this button right here, which will copy the URL to your clipboard. So if I return to the command terminal I can clone this repository by typing git clone and pasting the link in, and it will go ahead and clone that down. You can see over here in the file browser that there it is, and if I open it up, you'll see the 3 files that were shown earlier. Okay, and so what we want to do is we want to just edit this email file, and in our case, we'll just edit this to be something different. It can be my actual email, and that's all the changes we'll make. Pretty simple here. But then we can actually, if you type git status, if I move into that directory and type git status, you'll see that I've modified email.md and I need to add, make a commit. So I'm going to say git commit update email. Okay. So now that those changes are shown locally, but you can see that the origin master is one commit behind. So origin, remember, is the default name of the remote repository. That's GitHub in our case here, and master is the default branch. So if we want to push this back to GitHub, we can just simply type push origin master. It will ask us for our username and password. And then if we return to GitHub and refresh the screen, you'll see there's a commit message, update email associated with this string. And if we click on email.md, you'll see that the correct email that I had just updated was there. Okay, so that's simply cloning from GitHub, making changes and pushing back. But often we're collaborating with other people, and GitHub allows us some opportunity to, or some tools that allow us to do that efficiently. So if, let's say this change that I made, I want to get back to the original datum GitHub merge exercise, which it was forked from. So this was like a repository that I want to contribute to as an open source repository. So what I can do then is I can go to create a pull request, click on the pull request tab, click on new pull request, and that will allow me to then basically say that I want to go from the datum GitHub merge exercise, I want to go from John T. Foster GitHub merge exercise and commit those changes back into the datum one. Not only that, but here's where the real advantage is that it actually shows highlighted in red and green what the changes were, right? So originally the file had 2 lines of code, and I deleted the second line and corrected the first line to have my name, and so you can see that there. So we can go ahead and create this pull request. If you wanted to add a note, you could add it there, and then you can type create the pull request. And if there was any kind of automatic checks in place, they would go ahead and run against this. So oftentimes code bases will have automatic testing in place, and this would actually run those tests against the changes that you made, or I made in this case, in John T. Foster GitHub merge exercise, and would give us some information. So in this case, it says the branch has no conflicts with the base branch and can merge. And so you have the option here to do a standard merge commit, a squash merge, or something called a rebase merge, which we won't worry about at this point. Yeah, so in this case, I'm not going to do anything further. I don't actually want those changes to go back into datums, but nevertheless, this is how you'd go about doing that. Even if my pull request is never merged, it's always available associated with my account. So you can see here that the changes that I made locally are in fact there on my account. I just haven't had the pull request officially accepted from datum yet. But nevertheless, that's a little bit about GitHub and how we'll use it in this class. In most cases, we'll just the most common use case would be just to clone the repository, and we'll work on it locally, and then possibly push it back to your own repository in the cloud, and then rarely would you initiate a pull request. It was only if those changes you actually wanted to get back into the open source or upstream version of the code. So hopefully this was a helpful tutorial on Git and GitHub.